Hello, welcome to the video. This section we're looking at 5.5, where we're going to be performing function operations. So basically what we're going to be looking at is two different functions where they're going to be giving us a certain operation. So it could be addition, subtraction, multiplication, and division. Whatever function those happen to be, we are going to look at those operations and solve them accordingly. Remember all the rules of exponents, all the rules of radicals come into play, uh, the rules of variables come into play. So we've got to make sure that uh, those are being taken care of when we answer these types of problems. So here are both definitions and some examples of addition problems, subtraction problems, multiplication problems, and division problems. So basically here when you're adding them, so like here's one function, here's 5x, here's another functions, x plus 2. When you're adding them, simply add them together. Combine like terms um, accordingly. Again, using multiplication values and stuff like that. One of the things that you are going to kind of take a look at is um, domain of certain values. Basically, for the most part, x can be any value, but especially when you're looking at division, like in this example, there are some values of x that won't make this particular function a real solution value. So if I look at x here, well, x could not be negative 2 because negative 2 plus 2 is 0 and you can't divide by 0. So that would be uh, something for your domain that you would want to take a look at. So here it says let 3 be, or let f of x be 3 times the square root of x and g of x be negative 10 times the square root of x. They want you to find um, the addition of this, and then they want you to state the domain. Then they want you to evaluate when x equals 4. So you're going to go, basically you're just going to go 3 times by square root of x plus negative 10 times by square root of x. I just keep the parentheses in there just in case there's something that needs to be done, but in this case, we're good to go. We have like radicals, so we can take 3 plus negative 10, which is negative 7, so that's negative 7 times it by the square root of x. There's nothing else to do, so that is our result. The domain in this case is x must be greater than or equal to 0. Because if I had any negative number in there, I would get I would get no real solution. All right. So if I were to plug 4 in here, square root of 4 is 2. So now I got negative 7 times by 2. So that means that um, my result when, let's say like when x equals 2, f plus g of x would equal negative 14. So they're looking for two answers in that one. All right, so here it says let f of x be 3x cubed minus 2x squared plus 5. G of x is x cubed minus 3x squared plus 4x minus 2. Now we have f minus g. So this is where the parentheses are will be a little bit more useful. And then it's minus x cubed minus 3x squared plus 4x minus 2. Because it's subtraction, I'm going to get it out of the parentheses. So the first set of parentheses is written as is. If it's positive, leave it positive. If it's negative, leave it negative. Everything here, because it's subtraction, is now opposite. It is now minus x cubed. It's now plus 3x squared. It is now minus 4x. It is now plus 2. So, as we look through this, we have like terms here and here. So now this is, what, 2x cubed. Cross out. X squared's here and here. So now I have plus x squared. Cross out. I have minus 4x. Cross out. And then I have plus 7. So that is f minus g of x. The domain and range for that, or the domain would be, it can be any value for x, so it's going to be all real numbers. And they want you to find when x equals -2. So substitute all this in, so it turns into 2 times -2 cubed plus -2 squared minus 4 times by -2 plus 7. So now I got 2 times -8 plus, so that becomes 4. And then we have, this will be what, plus 8 plus 7. Finally, what I got to do is, this would be what, -16 plus 4 plus 8 plus 7. So when I take care of that, plus 4 plus 8 plus 7, so we got 3. So x, so, so we got f minus g of what, -2 would equal 3. All right, so here we have um, product. So now we have x squared times it by the square root of x. So essentially what I would do is I would rewrite this as x squared times it by x to the 1/2, because they have same base values, so then I can just add them together. 1/2, 2 plus 1/2 is, so let's just go 2 plus 1/2, so that would be, what, 5/2? So I got x to the 5/2 power. And they want you to evaluate when x is 9, but let's do the domain first. So is there anything that could make this undefined? Well, I'm going to say no. Actually, it'd be no, I'm sorry. You can't have, it must be greater than or equal to 0 because I got the square root of 2 in there, so it can't be negative. So everything would have to be positive for x. So when x is 9, so now I got 9 raised to the 5/2 power. I get what, 243. So when x equals 9, so it's going to be 9 to the 5/2. That'll be 243. Here we have quotients. So this will be what, 6x divided by x to the 3/4 power. So these are same bases, so I can subtract them. So this turns into x, 6x to the 1 minus 3/4. So now this would be 6x to the 1/4. Um, my domain in this case would have to be positives, so it had to be greater than or equal to 0. And then they're seeing what x is when 16, so I got 6 times it by 16 to the 1/4 power. 16 to the 1/4 is 2. 2 times 6 is 12. So this one here, with your graphing calculators, again, I'm not saying that you'd have to use a graphing calculator per se, but um, you can still solve these for sure. Um, I mean, let's do the plus one. So we go square root of x plus the square root of 9 minus x squared. Well, looking at it, there's nothing in common. So, actually, let's take a look at it as a graphing calculator. So if I type this in, let's put like square root of x try it again. Square root of x, close it, plus square root of 9 minus x squared, close it, and then we'll graph it. So it looks like that's our graph per se. And says our solution when x is 2. So if we go to looks like it's really close to like 3.7 or something like that. Second. Yeah, so yeah, so that's kind of how it is with the graphing calculator. So it would be, I would say when they said when x is 2, this f plus g of x is about, say like what is it, about 3 point, it was what, 3.6 or something like that. And that is being able to perform function operations. Hope this helps. Till next time.